Anyway, hi everyone. This is Shweta Mishra, and I am currently in Information Systems second semester, and it has been great. I come here from India, mostly the northern part of the India. I come from Varanasi, and I before coming here, I had worked 4 years at Barclays as a Java developer. So uh, it's a Python workshop, but I worked as a Java developer, and there I was responsible for different message processing and understanding how things were and communicating with the team. So those kind of things. And then I got bored. And my father started telling me that I should get married. So I ran from there and started my master's journey here, and it has been great. Listened to you all talking about AD, and I have been through it, and I have been through how we are all building in Python, and uh, it's all new, and like really encouraged by people who are trying to develop themselves, even if they are not from that background and still working on it. So it's a huge step, because the one thing that I feel when we are trying to learn is we do not block ourselves. So when we block ourselves by saying that, oh, I cannot do this, you will not be able to do it. So it's all about you trying to work on it. And Python is a very easy language because packages, everything is given. It's not a strongly typed language. It means you do not have to initialize variable like Java and have all those different things that Java has, making it confusing. Python is very straightforward, so you do scripting on it, you can do machine learning, you can do analysis, and even you can do something around Excel sheets, manipulating data, and removing anything that is boring for you. So I love to remove boring. I do not like doing presentations or Excel sheets work, so I kind of automate them. So Python helps you to do that. Then And Python is easy because you do not have to really install a huge software. It's just one Python software which is already inbuilt in MacBook. For Windows, they you have to install. Sadly, what I use generally is Jupyter Notebook and Spiders. It's weird why Python, Spider, and these kind of words are there, but yeah, they are like this. So it's funny, but it's interesting. So I think we can start with so my the workshop is kind of divided in first the basics of Python. So not very basic, like how to print, you know how to print, but little basic. Then going into NumPy, Pandas, and how you can do data visualization with it, and a little bit of a practice on data analysis that I have learned recently. So I think we could start with the first. So Python is interesting, and this section is more focused on what interviewers ask when they say, when you say that you are a Python developer, they generally ask certain questions. So I kind of made those, compiled those questions that they had asked me, and I'll tell you. One more thing I would want you to do is, one is practicing. So Python is all about you practicing. So keep practicing. Second is, even if you are stuck while giving an interview, like recently I had one and I was kind of stuck. So it's okay, and you can keep doing. So while you are coding, it's like you have to express your thoughts, and that is what they are looking for, and not the syntax. So even if it is a Java, Python, or any kind of a language, the logic is what is important rather than the syntax. But here we will look in how we can do syntax. So the first is like how Python numbers are there, and what all kind of formats it helps in. So so Python is amazing because it has complex number handling also with it. As you can see, the Cij is a complex number, so that's why it is mostly used in data analysis, because there are certain aspects in data there where things are imaginary. Imaginary numbers are handled in Python. through a simple way, not that you have to do certain things like you have to do it in Java. So you can check a data type of a particular variable through type. So I would want you all to like go on, like it's already here, and you could copy it and you could check on your own how can you use type. So for example, if I have a variable d and I call it hello, and I kind of ask what it is. So I think the last one, it will give me string. So you could check with this type variable type function that Python provides. It's an inbuilt function. You do not have to write anything. So what it actually can help you tell. So this was one of the questions that I had asked. I was asked in the interview where they kind of asked me, can complex number be handled in Python? So it just came up. The next part is casting. Python can, you can typecast, so you can make it a integer, you can make it a float, you can make it a string by just writing numbers like this, and it will easily be shown on your screen. And then there is list. So a very basic questions that generally is asked is the difference between list, tuple, and set. So I kind of gave a short sentence which can give you an idea. One basic difference in list, tuple, and set is that the list is shown is initialized through a bracket, a square bracket. Tuple is initialized through the round bracket, and the set is initialized through a curly bracket. So this is the differentiator. Other than that, you see it's very simple. What you can see in list is it is ordered, changeable, and allows duplicate value. So you can have duplicate value. For example, I want to add a cherry, so I will be getting a cherry in the output. So it is ordered, so it will always give me the output in this manner, and the manner won't change. It was indexed, which means that it is from 0, 1, 2, 3. That is the index. So if you want to find like what is on the 0th index, it will give you apple. So that is why array a list is used, where you can get a list of things which is ordered, and you can have duplicate values. This is very general things that is being used. Tuples is, on the other hand, is it is ordered but it is not changeable. So I can do manipulation on list, but I cannot do manipulation on tuples. So that is one key difference that we have. So and you can have a duplicate value. So here there are duplicate values. I can have any kind of value. It is ordered, so it also has index 0, 1, 2, 3. But the only major difference is you cannot manipulate tuples. So that is why tuples are generally not used, because generally we would want to play around with data. But if you do not want to change the data, you use tuples. Then there is set. Set is a different set. Like overall, so it is unordered, it is unchangeable, and it has no index. So just a random thing you want to add. So as you can see, I have two apples in this, but it only prints one apple, and it doesn't print like the apple is not first. So whatever it could be, there could be some use case where set is used, but I've not really used set that often. So that is set. Then there is dictionary. Now dictionary is also a kind of a way where you can store data. That is like it is ordered, it is changeable, and it does not allow duplicate. So now this is a dictionary. It has key value pair. Now key means brand is a key, and value of it is 4. So why dictionary is used is if you want to find a particular, if you want to label something. So you could have brand, and you could get the data out of it without under thinking of where the data is. Without looking at the indexes, you could directly get it through the label. Now here it says it is does not allow duplicates. So it does not allow duplicate in the key. key place. It will allow duplicate in the value placed. So if you want to experiment, you could try. So this is a tricky question which they asked in the interview, where it kind of makes you confused that maybe duplicates. So both the things cannot be duplicates. So here it should give me a, a error. So like I have year one is not duplicate, and this is 1964 is duplicate. So it kind of gave me that, and I can write. It gives me 1994. So you could get, like, if there is any question, let me know, or we will actually move ahead. So that's dictionary. So I think we can again redo what I was talking about, the list, tuple, set, and dictionary. So list is ordered, changeable, and allow duplicate. Tuples is ordered, unchangeable, and it allows duplicate. Set is unordered, unchangeable, and unindexed. And dictionary is ordered, changeable, and does not allow duplicates. So this sheet is available. Oh, yes, I forgot.
I can also zoom in this, like make quick.
Oh, okay, okay. Is it better? No. Okay. So, so yeah, I was talking about function. So the function, the standard way of defining a function is using DEF. So that is like defining a function. A function can be of any name. You can pass a parameter, or you do not want to, you can not pass a parameter, and you can write certain things in it, and then call it somewhere, and then it will do whatever you have asked to do. This is just a simple example of doing this. And now this is lambda. Now lambda is a very new concept, not very new, but yeah, it is a very exciting concept for people, and they generally ask lambdas. It is there in Java, it's here in Python as well. So lambda is just a function, but it is not written as a function. So as you can see here, here we have def, my function, and f name. So instead of that, in lambda, if I had to do what I am doing here, here I'm adding a plus b plus c, a very simple step. So if I had to do this, I would have written my function, and I would have passed a, b, and c, and then I would have written this, and then I would have said that you should do a plus b plus c, and then it would print me the result. But for lambda, what you can do is you can just instead of def, you can initialize a variable, and instead of my function, you could remove this whole thing, and you need this. And then here, instead of function, what I wrote is lambda, and it will be just like what is here. So it's a very easy way of writing. Why we are using lambda is to make it more readable. So now this is more readable. I do not have to go back somewhere, find the function, and then understand what the function is doing. But certain operations can be done quickly and easy, not quickly, but like it's just helping you in reading a particular thing. So that's lambda. Now we have object orientation in Python as well. So it's a concept where you have a class, you have an object. So class means an entity. So a class would be a person, place, animal, bird, or thing, and a object is like a instance of the class, like something that you initialize somewhere, and then you could call that class from some other place. So that's like a simple way of explaining what is class and object. So you could do that in Python. You can define a class using the same normal way of class, person, this, and then you can define a method inside the class or a function inside a class, and then pass certain parameters in it, and then you can have p1 is my object, and p1 is equal to person, what is its name, what is its age, I have passed that, and then I can print that using p1, like name and age. And you can do a lot of things in classes. This is just an introduction to what class is. So you could do manipulation of objects in the class. You could do other different things to make in you also use inheritance and all those concepts here. So that is what is doing. Then we move on to, so even if you have, like for example, there is something called as abstraction that we have in our Java. So if I have to have a class but I do not know what to do, Python would give me an error here. If I, so if I run this, yeah, uh, it would give me a weird error which I don't understand. So if you need to write pass in it, and this will not give you an error. So it means that the class exists, but right now I do not have anything written in the class. So this is for the generally I use this for when I am coding and I have certain things in my mind that I have to do this, but I don't know what to do inside it. So I would use this function. So this is a good thing to know. Then ha- this is like a simple program where I am uh, having a class. I am defining certain methods in it, and then I am trying to do different things, like printing the information. I am changing my age, so just so that you know that you can change age object, and then deleting certain thing if I want to delete a particular object, and then uh, printing the information. So if I uh, so here you can see what I'm doing is I am having a class person, and in this class person I have defined initialized something called as name and age, and then I have a method where I will print the name and age in this fashion. So if you see F here, this is something called as string format literals. So it's like formatting your string inside the code. So you could do string formatting. So it's a concept in Python where you use F so that it can format. And then it is then there is this particular method to modify the age. So if I want a new age, I can modify, and there is a particular way of deleting a particular object. So if I say self, it will delete. So that's like a simple way of deleting object. So and then I've called these methods in this, so you can pass Alice with an age, and it will print a value saying Alice is 25 years old. You can pass you can set a age to 30, and then it will print 30 years old, and you can delete it, and then it will again print 30 years old. Then then comes like a normal data manipulation thing that we do in data science. So for example, if you have a list of data, how will you iterate in the data? You can use date. Date is also a method that Python has provided. We can leverage that and get a date. You can format the date in a certain format if you want. And how can you make the dictionary? So that is what I am doing currently. So I have imported JSON. JSON means it's a key value object. Now what key value object means is it looks something like this. So a JSON object generally has a key name and a value Alice. So and it has to be written like this. So this format, so there are few formats that people work on in Python. It could be XML format where you have tags. It could be JSON format. It could be CSV. So these are the ways, files in which the data is stored, and we can use those files and do data manipulation. So it's just to give you an idea about what all data can be here. So for example, I have uh, define a list of numbers. So I've defined a list, and I am iterating those number using iter function. So it helps you iterate the function, and then using a for loop you can print the different numbers. So this is a common questions asked, like how do you print a number in an array? So you could do this by just 4 lines of code. So it's just defining certain numbers, uh, using a itr function and saving it here, and then for all the numbers in the number itr, print all the so it will print everything. Uh, then there is something called as date. Date is a great way of experimenting. If you want to, you can do today is equal to date dot today. It will print today's date. And then how do you want the date to be printed? So different formats, DDYY, or so here percentage B means word. So it will show you like March. D means the number, so date, and the Y is the year. And then AB means A would be like what is today's date. It is Friday, so it should print Friday, and March, and D and Y. So this is used majorly in data analysis when you have a very weird data in which you have certain values where some dates are in DDYY format, some dates are not in MMYY format, and you need your data to be consistent. So to maintain the consistency, you will need to use it on your data frame. So that's about date. We have something called as dictionary of so this is like a dictionary that I have had. Then I use json.dump. J, so you if you want to use different files, so for example CSV, JSON, or any other file, you need to import those things. So for CSV, use import CSV, and then use the functions. So for JSON you need to import CSV, import JSON, and you print that JSON string. uh, then there is something called as regex. Regex is a very common thing also. Again, why? Because the data can be very weird again, and you would want the data to be consistent, so you would remove certain values, so or certain strings. So for that regex pattern, or for validations, you could use this particular thing. So for example, I make that this is my pattern. So and then it will search for the pattern, and then text, and then it will tell that, yeah, matching text Fox. So I have asked like um, what is the matching text, and it will return me what it is. So that is what I am doing here. So for regex I have imported something called as re, regular expression. So that is the package that I have used here. You could write your own code also to do regex, but we have Python and it has provided date and reg values. Now we go on to the normal input user. So generally we want the user to input something. So for that you use the input function, and then it will show a box. So for example, if um, so here, see. So when you write input, it will say something, and so it will give you. So as I said, F will get you all the things concatenated together. So this is like a way of um, manipulating a string value. So string is a manipulated. String can be manipulated. That is also a question that is generally asked. Can you change values in the string? Yeah, you can. Then the next step is file handling. So generally we would want to handle files because when we are doing data analysis, there are times when the file is not present, or the file is corrupted, or there is some other issue. So for that scenario, we should try to handle a file. So we would import os is operating system. So it will check the file from your monitor or wherever the code is deployed. Uh, so there is something called as try except block that we have. So try catch, you might remember from Java. So it's just similar, but like try except. It's a good to do approach of writing in Python, having a try catch block so that you always catch a error and the system goes down gracefully. It's a standard way of doing in industry. So you always have a try catch block. Then there is something called as with. So with is like a syntax which helps you do operations in a file. So you say open file1.txt, and here you pass w means write. You can pass r means read, or you can pass a means append. So there is no example here, but you could append two files if you want to. So those are some things. So for here what I'm doing is I am opening a file and or creating a file and writing this particular term in it, and then I will read the content of the file, and I will save it in the file one contents. And then I want to have another file, so I'll say file 2, and I will add the content of the file 1 in the file 2 file using this. So this is like creating another file 2, and I want to delete file 1. Now it's of no use, so I'll use os.remove to delete the file, and this is going to give me like the content of what is inside file 2. For example, there is a certain exception that occurs, so you have to catch that. So I will say that there is an error, or you can be specific about what the error has occurred in that file. So that is in this case. So this is a very important part, because if you do not handle your file well, it is not going to be really good. And then I showed you how to read, write, append, and delete a file. So it's like you can do data manipulation using. So it's not like just this. You can use CSV and other kind of files also here. Now is the part of NumPy. So the basics are gone. Now we can say NumPy. So NumPy means numerical Python. So every numerical arrays and data are all handled through a library called NumPy. So it generally import NumPy. As NP means you are just importing it as NP. It's not necessary that you use it NP. You can say SW, you can say whatever, but a common practice is NP. uh, and then you can create like a array. So as you can see here, I have used numpy random function, and in that random functions I have defined like three comma 4, it means the first argument 3 is the number of rows, and second argument 4 specifies the number of columns in the array. So I am defining a array and then I'm just printing it. So this is just a random way of defining array. You could define a 2D array using the brackets, but this is one. You can find indexes. For example, what is the element at the index 0 and 1? So you can use this kind of a syntax and find out what is 0 and 1. Slicing means you can remove certain values from a particular array. You can find the data type of the array. So this is a data type thing. Then you can have view. So a dot view is just a view of the array. It's like you can only view it, it's not physical. So it's not going like see, you cannot do anything on it, you cannot manipulate, but you can make a copy. So I want to make a copy of a, and then I can do certain things on c and it will actually happen. So that is what uh, here, like a difference about view and copy. So what it means, it's a general question that is asked, and then you can do a copy. You can modify your array in certain ways. uh, and then there is shape. Uh, what is the shape of array? So it is a 2 by 2 array. So I would say that this is the shape. So to get the shape of an array is what I write. So it could be a 4 by 4 array. To understand more about a particular thing is why we use shape. This is more generally, so now we are only looking at a small amount of data, but when there is a huge data and you want to look into Excel sheet, you generally use shape, so that you know how much of the data are you looking at. You could reshape it to 2 by 3 matrix. So that is what I am making it do. So that is what it is. You can iterate through array. Now how to iterate is for a particular number in numpy dot ndeter. So here it will iterate through arrays like 1 2 3 4 5 6. So you can go through in this loop and then print the values in it. uh, then there is join. So you can join, concatenate two arrays. So for example, I have a G and a H array, and I already had a B array. So I will use something called as np.concatenate function. It is used in it's a NumPy function. So you can concatenate two different array into one. So this is also a general coding questions that is asked, that if you have two arrays, how will you join them? You could use concatenate function, and it's joined. And then you have to split of a array. So I have this big of a array, and now I want to split it in four. So four means it's an index. So you can split 0, 1, 2, 3, 4. So one array is 1, 2, 3, 4, 5, and one array will be 6, 7, 8. Split is generally used in data analysis when you have to make two data sets. One is for training and one is for testing. So these two data sets help you make your data. So that's why. So on training, you train your model. On testing, you test. So that's why split is generally used. Uh, then find the index of the element that needs. So if you want to have a particular index, so if k is less than 3, then it will print certain values. So uh, this is to iterate through values. It's used to have operations, like you want to do a certain operation on a particular value. So if it is less than 3, then what are the values? So that is what you can do here uh, through np.where. Then np.sort will sort your array. So very common questions people ask, how will you sort a particular array? So you could just use sort. there is a way where you can sort like for I is equal to write a big code, but this is like something NumPy has provided, so you can directly sort your array. And this is the output that I was talking about of all the values and how it has given the output. So I think it is shared with you, so you can check it out how, and you can also do certain experiment on this. Like I want to concatenate one more. So how will you do that? Uh,
In concat, it will suppose I have two arrays, like 1, 2, 3, and again 1, 2, 3. So what it will do, ascending or descending? How it will concat?
so it will just concat 789
The first array
789.
and second array. That's it.
Yes.
It will not change the order.
No. You can do the ordering one, but I think it's done through sorting, and then you could make it an order. Hmm. Uh, Sort in the parenthesis is what the variable that you want to sort. So m means uh, this is the variable. So all the values of m will be sorted.
Ascending order.
Yeah, yeah, ascending order. Yes, ascending order. So that's there. So there is an explanation about it. Now, now there is something where you can see visualization. So Seaborn, Matplotlib is used for creating your charts. So now we can see random dot seed means you want a random 42 numbers, so it's just different numbers that are going to be there. Then you can have your data normalized in different ways. So NumPy has a random package in which you can use normal, binomial, logistic, and chi-square. There are more of these, but this is the four that I have used. So uh, in these ways, your data can be distributed. So that's why it is used here. Mm. Then you can plot your graph through SNS, means Seaborn. Seaborn SNS is what I have imported. So yeah, so that package dot histogram plot. You can plot other graph also. So this is for histogram, and then what data you want. So this is the data. KD is equal to true means I want all the data in one chart itself. So that's why if you make it false, there will be four different charts written here. Beans is equal to 30 means what would be the separation between the two charts. So you can see white lines between, so that separation is what beans is giving. Color, you can define colors. So if you do not want colors, you can remove it, but color give you more visualized appearance. So that's why this is the function that we can pass, and then it will plot the chart. Now it has to show the plot. So for plotting, we have to use plt.show. That will show the chart. The plt.legend means anything that is coming over here. So normal distribution, binomial distribution, and its line. So you can define what you are seeing in a chart. You can set your font scale. You can set your context, set your style. So dark grid means this is the grid that you are seeing. So all of these values is what is there in this. So it's just an overview of how you could use uh, NumPy and Matplotlib for data visualization. So this is something which you can read about. Then there are different functions. There is something called as u function. So you can do mathematics in Python. So that's why Python is mostly used in data science, because there are fields where you are working with big huge mathematical problems. So you could use log, sum for summation. You can find LCM, GCD. You can do trigonometry, have sine, cos, all those things. You can intersect arrays. You can can union of two arrays, you can set difference in the two arrays, or like symmetric difference of a array, it can also be seen through these functions. So that's why it's just an introduction, and you could use all of these functions. So as I saw, there's a logarithm of each element in an array, so it will show you the log value, it will show you the sum of all the values, it will show you LCM, it will show you GCD, it will show you sign of each values, it will show you intersection of the arrays. There is nothing that is intersection, there is a union of arrays, so two two arrays are becoming one. Then the differences in the two arrays, and what is the symmetric difference in an array. So that's, so just some maths problem that you can do through just NumPy and a particular function, log, sum, LCM, reduce, GCD, sign, and these. So you could go back and check what all you want to do and make certain experiments out of it. So up to you. And then there is a little bit of its explanation. Now NumPy gives you numbers, so that's why it's numerical Python. There is Pandas, and now Pandas is for your data frames. So you have data, you have a key, you have a value, and that's why Pandas comes into picture. So here we have, for example, there is a data. So this is a data that I have where there is name, this is the name, age, gender, country, salary. Then I will make a pandas data frame, which I will define as df, uh, and then pass on the data. So generally in data science, the first thing that we do after reading a particular CSV is define a data frame and add all the data in that data frame. uh, Now, one best practice that I feel the people in industry want is having a defined variable name. So people like me do not really put efforts in and defining a name. So I just wrote df. Df means what? Doesn't really make sense to a new programmer. So that's why you always keep in mind while coding that you have your variables defined with a specific name, which is understandable, readable to the user. And that's it. This is a function in pandas data frame, and it will make a data frame out of it. Now data frame to CSV means I am writing all of this data into a CSV called data.csv, and I do not want to give any index. Index false is equal to means generally pandas will add index value in it. So you will have 1 0 1 2 3 4 5 column, which I do not want. So that's why I make it false. You could do it true if you want. Then I can do it to JSON also. So I have a data.json file, and inside that file, all of this record would be written in this particular way. So that's just how you can write your data frame into a CSV. Then when you have, if you have a CSV that you already have a CSV and you want to read the CSV, so you could use read CSV, and you can read that data. So this is one statement which is generally used when you do data science. First thing is you read the CSV. So you have a huge training data set, you want to read it and you want to store it into a data frame, which will be a CSV. Similarly, you can do it in JSON. So why JSON is used, for me it would be for config files. So in industry, you do not save your password or anything in your code, but you always have a configuration file, and that configuration or a properties file will be a JSON or a dot property file. So or a text file. So you always try to have like no object, like nothing that you need to change in the code. It should be code only, and these values should go in your configuration files or username, password, or any database string that you would be connecting to. Those strings should go in a that file, so that when there is a chance, if you want to change the data set, you want to change the file name, you do not go and change it in the code, you go and change it into the config file, so the code is not getting hampered, it's just the configuration file. So it's a concept that we use in the industry, so that's why JSON is something I had added here, so that you are familiar with it and you know that you would use a config file, and that is why it's there. Now, analyze the data. The common way of analyzing the data is to see the data. Sometimes the Excel sheet is too big, and to open it on Windows, my Windows will crash. So that's why we have df.describe. So it kind of describes the data, like it gives me a count of age, it gives me different values, so that is why there is describe. Then there is something where you can clean the data. So the drop NA means any data place where there is a null value in it. So sometimes your data, so the first thing in data science is reading the data, then cleaning your data. So you do not need random values, no values in it, or zero in it. So that's why null values or anything which you just drop those. So that's why there is drop. And then when you have a clean data, you find the correlation. So there are lot of features. So features means the columns. So when you have all of these columns, you want to find what is most related to. So for example, I want to understand it will rain tomorrow or not. I have a data where it says yes, it will rain if there is these conditions. So if humidity is this much, if the weather is this much, if the time is this much. So what is more correlated? So humidity and rain is more correlated. So I'll only use these two to build on my model, to train my model. So I would remove other not usable data set. Like, so if so like I'm trying to just simplify how what is the thought process between finding correlation. So that is that. Then there is create a scatter plot. Obviously you would want to plot the data because it's a fancy way of seeing the data. I do not want to go into Excel sheet and look all the numbers and understand nothing, but this actually gives me a very standardized way, like 25, the age of 25 have salary this much. So this is like a simple way of understanding the data, that as old you are, the salary would be more. So just understanding the data.
Can we read XML also? Yeah.
You could read XML, but then you would have to do a lot more regex in it, because there are those tags. So you would have to identify the tags. CSV and JSON is easy to use because it already has a key value kind of a function. So Python is, it's easy to do it in this. Okay. So eh, how are you guys feeling? Bored, or I don't know? Because it's 1 hour already, and uh if you, do you think it's too fast?
No, it's going
Hmm?
well. No, it's going well.
Okay, like you are getting some input out of
Yes.
this, right? Do you want like a break, 5 minutes? Want to go to the washroom? Nobody wants break? Yeah, because I have given a lot of information. I don't know, so maybe you could have a look on the book notebook that we have given on the Zoom, and see if you find anything useful, or you want to suggest something, or if you have any question, and I could give you 5 minutes to just process.
I have one question. So in one of the examples you explained about self. So can you explain us how exactly it works?
Self, yes.
Self, name, age.
So like so the self parameter refers to the instance of the class that is being created. So it's like you it is a syntax in Python that it will refer to that instance of the class. That is why it's there. So that's the only reason.
Name is the instance for the particular class.
Yes, yes. And init means init is defined inside, uh, so it's like initializing that particular thing. So init means initialization.
Yeah, because I thought you had a specific question. Feel free to ask you. Which is your for? What topics are you guys most interested in? Should it be focusing on numbers or you guys have something like particular that you are more interested in something else?
That's good.
Yeah, I'll just take good.
That is fine. I'm fine with good. So yeah, matlab, we are almost there. So do not worry if you are getting bored. That so it's mostly now about data visualization. The next part would be, and a little bit about data science. So data science is a subject that I took this semester. I have no experience in data science at all, and with the knowledge that I have up till now, we have learned till classification, and it was really good experience and it was very interesting. That's why I have added it, so that you have a slight idea about what data science is. Because in data science generally Python is used, and NumPy and Pandas are the two most important libraries being used, and after that cplot and matplotlib for graphs. So that's why I have included those things, so that you know those libraries, and if you have time, go back to your laptop and check what you can do more, how you can make sense of out of a data. So this whole process is just making sense of a data. Like data is huge, but like what can you make out of it, what can you predict, what is the accuracy, all of these questions is what is being asked. That's why you should kind of know all of this. So I can start with something around data visualization. So I have already you have already seen a graph, and you have already seen matplotlib being used. It's a library, and so for matplotlib there are different ways you can plot different graphs. So here what you see is I am having a sample data, uh, uh, which can have the legs from uh, so 0 is the starting value of the sequence, so 0, 10 is the ending value of the sequence, so 0 to 10, and I want 100 values of the sequence, so there will be 100 floating point values. So that's why this is something I saw. And then y, so you for plotting you always think in 2D. So x and y coordinates is what you want. So even in data science, when you are training data set, predicting data set, two different areas, so x and y is something which is very important. So that's why I have already initialized my x and y. Now I'll just plot my x and y through different ways. The first is the line plot. So for line plot, you can use just plt.plot xy and have labels and then title them something and then plt.show. So plt.show is a common way of uh, giving an output. So your output is what comes here through plt.show. Now, how line plot will look like is this. So I have a sine wave. So this is a simple line plot. So as per your data, you would need different plots. So first is line plot. Second is scatter plot. Scatter plot means all the data points will be somewhere, somewhere, somewhere. To just understand about the data, it would look like this. If you can see. So it's like a random scatter plot. So all of the points, whichever is there, is plotted over here, and it's a random plot that is being plotted. Then random plot, scatter plot. Then there is bar chart. So you would want to have bars. So that's why common bar chart. So uh, for bar chart, you need to use bar function. For scatter, you need to use scatter. So that's the only difference. Nothing else that is different. And then have label, title, and show. So that's there. Then having a histogram, for that you can say HIST. Bins means, as I said, it will be separated through a certain distance. So as you can see, this is a histogram, and the white line is what bins is what specifies. So you can change this value and see how your data looks. So that's why it is X, Y, title, show. So this is the data visualization thing. Now we are in the actual world scenario where you have two data set, training and testing. Those two are also shared with you on the Zoom link. So you could go and check out how the training and testing data set is. Now I'll give you a little hint about what this data set is about a person who would have diseases. So it has different diseases, and what are the symptoms to cause that particular disease. So, for example, if I have diarrhea, the symptoms of itchiness is more, or the symptoms of loose motion is more. So, what is more? So, that kind of a data is what you can see. I have imported all the libraries first. It's a good practice to always import your libraries at the top so that anyone new who is reading, they know that these are the libraries being used. So they know that this is what we have to do. Sometimes what I do is, generally when I have to write a code, I'll use that library. Generally I copy paste from Google. So you go to the Google, you see there is one library, you copy the whole code and you paste it. So instead of doing that, just cut the library part and import it at the first, so that someone new comes up and they will see, okay, these are the libraries that are being there. So a set where all the libraries are present. Then I am making a data frame. First is the training data frame. So I read from the training.csv file. The training.csv file is in my same folder. So you need to also be careful about where your training data set is. If it's in a different folder, you need to specify the folder. Otherwise, it will say file not found. So that is one tip. Then it will read the data set, it will save it in the training data frame. Then df.head is defining the data set. So I do not want to go and click on the CSV and see what it is. So I'll just say dot head, and it will give me what all columns are there, and so like few rows of how the data looks like. So you can see there's itchy, rash, skin, something, sneezing, shivering, and there are values 1010. So if you have a symptom of itching, it gives 1. So yes, you have a symptom of itching, and so your prognosis is that you have a fungal infection. So so this gives me like a understanding of, okay, there are few 1 zeros in my data set. There is one column where there is written something, and there is one column where it's a nothing is there, NaN. So, and it's unnamed, but something is there. So you can get a overview of what. So that's why we use head. Then to understand, as I said, we kind of want to know about the hugeness of our data set, so how big it is. So that's why shape. So it gives me that it is having 4920 uh, uh, 492 by 134. This is the shape of my data frame. So that is there. Then there is definition plot nas. Nas means, so this is my class, this is my function that I'm trying to make, that will pick all the values that have nothing in it, all the na values. So you saw, right, there is one whole column with any value. So I kind of made that function where I am looking if there is null. So is null is a function also in data frame, in pandas. So is null, and I will just sum all of the nulls and is not equal to 0. Then I'll do all of this, else I will say no nulls found. So I'm just checking how many nulls are there, and I am kind of plotting that data. And so plot NAS can give me this plot that there are this much NANs. So it's like 133. So this much NANs are there. So we have a data that is not being used. That's why I would want to remove it. So for that, I will use the drop function, and I will say drop this particular column because that is what the name came, and axis 1. So it will kind of drop that data, and then I'll check again if there are any nans. So I'll just see, okay, there is nothing, and so it is fine. Now the data set is good to go. So the first thing is like data cleaning. So this is a small way of doing data cleaning there. So this data is very clean, because it is introductory session. I didn't get a data which is very bad, because there are certain data which could be bad, like you would have 0, you would have certain value in it, and it's not good. So a concept called categorical values and non-categorical values is coming into the picture. Like I only want, for classification, I only want numbers, and I do not want any string in it. So we need to convert it into numbers. So there is a something concept which is not here in this, but something called as one hot encoding. You can check, it's a function, one hot encoding, and that is a way where you can change all the number, all the values that is given here. For example, fungal infection, I can change it to 0 or 1. So it's good to have, so for classification you always have to have numbers in it and no values in it, so that you can do good classification well. So that's a tip. Then we are done with the training data set. I have to given two CSV. First is training, second is testing. So now is the testing CSV. So it's the same process. I will see. So always there is a difference between training and testing. Training is kind of having a more data than the testing data. Training data should not be same as the testing data, otherwise you will not find your how your model is working on other different data. So why we are differentiating is the model kind of trains on a data and understand, okay, this is the pattern, and it understands, and then whenever there is a new data given to it, it will understand that, okay, there is new data, and it will give you certain analysis. If your training and testing data are same, it will give you same values, and then it will not really work well with your other data set. So it will not predict well, or it will not give you the right analysis. So that's why you always make sure that your training and testing data are different. And that is why we here, as I have two CSV, training, testing, I didn't split, but sometimes we only have some data. So you kind of split your data into 80 um, 80-20 ratio, so that your 80% of the data is only training and the 20% is left out and it can be used to test. So that's there. And then you can check what is there in the test data frame. So this is the test data frame. It is also same as the training, like the columns are same but the values are different. So that's something. Now what I am trying to do is I so as you can see there is something called as prognosis. So I want to actually find some values around prognosis, and I do not want to use it for my models. Like my I do not want my model to know about prognosis. So I'll make it as a y for all of my x's. So that's there. Then do so here what I'm doing is concatenating two data frames, training and testing data frame. So now I have a huge data set which is 4962 columns, rows into 133 columns. So this is the huge data set that I got from both the data set. And then I will say label encoder. So label encoder, there is something sklearn. First of all, this is a new library called sklearn. Sklearn is generally used for machine learning processes, for classifications, for your pre-processing. So this is one library that we can leverage. Now sklearn, and you can import pre-processing and say label encoder, and then you can say prognosis. As I told you, there is one thing called as one hot encoding, there is one thing called as label encoder. So as I said, I do not want to work with string data like fungal infection or all those words. I would want to work with the numbers because it's easy. So that's why I convert all of my data into numbers. So the as previously prognosis had string in it, I converted it into numbers. So now it's kind of fine for my Python to understand what it is. The next step is to understand null values. So in SNS, there is also one way of data visualization that is called as heat map. So heat map is a way where you can see the colors, and that will show you how many um, values are present. And as per the color difference, like this heat map is just blue, but there is always a color difference. So it will go from blue to white. That color difference kind of helps you to understand how your data is. So this heat maps tells me that there is no null value. So is null is a way to understand if there is a null value in it, and or not, and then it will plot those points for all these. These are the rows, first row, like these are the column names. So that is what is shown here. Then again, as I told you about split, we can split our data set, and here I am trying to split using this syntax. So ILOC means location. So at the location of 4920, I want my data set before, or so here this symbol means before. So before all 4920 columns, I want all those to go in the train, and after those we should go in the test. So this this particular, I don't know what it is called, colon, is used to say before or after. You could have this here in this line after point, and you could have this here, and then it will dedicate all the values after 4920 to the train data set. So that's the difference in this line. So I have, what done is split the data set again into training and testing. uh, why I concatenated, I told you to remove the string values. Now I do not need the concatenation, I want to split, so I have done the split. Then I have test data set. So I split the data set after 4920. Split point is 4920. After that, whatever is called test data set. And I have done a reset index because 4920, then 4921, 2324, likewise the data would come, but I want my test to be numbered as 1 2 3 4 5 6, so that's why reset indexes. So I say that you just reset the index and then I drop the index value so that there is no confusion. I do not want the index column. So that's the test data frame, and you can see this is the test data frame, and you can see the output. So test is just 42 rows, while as the the train is 4920 rows. So it means the split is done properly. Now now this is something called as box cox transformation. So why we are using this is to make consistency in our data, because like normalization. So normalizing your data sets, something around those lines is what it is doing. If there are any null values, I want to normalize those. Because we just splitted the data and maybe there are certain data we missed, so we would want to normalize it. So that's why this particular function is written. uh, it's not something I would say that you just because this is introductory you wouldn't need it, but you can use this for your pre-processing of your data. And then you can find what is the length of columns in the data using columns. You can find length of rows using this syntax. So length will give you length. There is also something called as dot length that also gives you certain values. So just a single thing can be done in multiple ways. I prefer doing it this way. You could do it in your way. Then concat dot head, just to understand what is inside concatenation. So it kind of printed all the values that are there and its head. So that's just there. And then I want to plot the histogram. So as I told you that we can plot histogram. So I want to see what are the datas for each column. So for eaching what is the frequency, and what can be done. So around those, like how many values have like around 6 to 7 and then 0 to 1. So those bits are written over here, so to understand that you can plot a histogram and find the value. Then you could also plot graph. So just for all the values that are there. So eh, that's what is doing in this function. So this is the function, and I am calling the function and I'm giving it a data frame. So concat data frame, and then it is going to do all the things that need to be done. It's kind of straightforward, not something where you need to like know something, because you know what plt.figure would do. It will print a figure. What is this for loop for? The for loop is for to understand all the columns, and then it is to list all the values in that columns, and then it will plot different data histogram in it. So that is a thing. Then I want to check outliers. Now, in data sets, outliers is a concept we have. So, what outliers are? There are few data points which are out of the group. So those are called outliers. So I would want to check how many of them are there, how many of them are not there. So I have made a function to understand the outliers. And this function will give me like the lower bound number means what is the lowest for vomiting. I can see -3 is the lowest, and the upper bound means 2.9, what is the highest, and how many outliers are there. So, in between these two bounds, how many numbers are there which are not present in these two? like the lower group and the higher group. So those are outliers. So this is also a way where you can analyze your data and say, okay, there is burning something, some word. So this burning thing is having lot of outliers. Maybe the burning thing is not related to your analysis, so you could drop burning one. Or you can find what weight loss. Weight loss is having a lot of outliers, so maybe weight loss is not really impacting in certain ways, and so I do not really use this, so I can remove it. That's why we can check outliers through this thing. Then heat map, as I said, this is the way where you can see your heat map, and you can understand, okay, where, what is the major value where it is more, so like throat irritation, runny nose, all of this is like something which has impacted, which has more correlation. So to understand correlation between two things, so how all of this is correlated, so how itching is correlated to prognosis. So those distances you can get from this data. And uh, so for correlation, as I said, there is just one function called CORR. It kind of finds the correlation for you, and this correlation can be plotted. So as I have written, heat map correlation, so it has all the data from this inside correlation, and it is used here, and it is getting plotted in this heat map. So this is a way of visualizing the data. Then I can kind of find how many features are there which are correlated. So there are 59 features, and what are those features that are highly correlated or that are not correlated. So these are the features which are not correlated, and I do not need them, so I kind of drop them. So this is like particular. So correlation, this zero point 0.7 is a value that I chose. You could choose it something else and make your model better, or so it's all depending upon your correlation value. So this is like a correlation where you can change it, and to find the correlation value, as I said, you can use CORR and find the correlation value. So I chose zero point 0.7, and in that range, I saw that these many values came, and I do not want them. So I'll drop them from my trained data set, and I'll drop them from my test data set also, so that I have a consistent data set. So one error that I've always faced it is that my model is trained on some values, like for example 3 values, but my test is only having 2 values, and then my model would give me error. So we need to check that our data is consistent. So it always has, like, if for example test is having 3 values, train should also have 3 values.
So there is no other way to make it consistent if it is inconsistent.
You can add data,
Okay.
just a dummy data. So that's a way of making it consistent. You could add null values in it, or you could remove that third value from your data because it's not there in your test. So you could remove that. That's there could be more, but I only know this much. Uh, then yeah, so from train I am dropping prognosis because now I do not need the prognosis part, because I want my model to run without knowing what it has to predict. So that is something what is doing. This is again a heat map where I am making it a triangle. So so you can see, like, this is because it has like huge data set, it's not very visible. But for small data sets, like, there is something called as lone data set, there is something called as iris data set. If you go on Kaggle, you can find it's a better picture, but this is what it drew. So what am I doing is again finding correlation and uh, plotting a graph. So a correlation graph could be like this. A correlation graph could be like the one that I showed here. This So whatever is your preference, you could do. This is just something I um, wanted to share, so I've added it. And then variance inflation factor. This is also there is a library called stats model. Now it's not something that is, it's just good to know thing. It's not used because generally your data set is not this good. My data set felt very good because everything was similar. So that's why I kind of added some more outliers, and I added bad things so that my accuracy goes down. So you could do that to your data set and play around. So you could check variance inflation factor and understand what is the index for all of it, and then drop those values at that index. So it's as it is saying that irritability. So for a column called irritability at index 86, index is like the array index that I was talking about. So it will drop all the values after that, so that there is some inconsistency that happens in the data set, and the data set doesn't give me 100%. Then comes the classification, like the crux of it. So the whole major work is being done in cleaning the data set. So up till now we were just cleaning, understanding the data. So that's why in data analysis the major part is understanding data, cleaning data, making it consistent, giving, removing outliers, all of this. And then you just have to use the model. So the random forest classifier, every model has their libraries, so you just have to import them and then use it and find the score. Use your X train and Y train. As you have seen, I had splitted the data into X and Y. So if you go, like, I can show you here. So you can see I have dropped the prognosis column. So it's on you what you want X and Y. So to understand your X and Y, you do feature analysis. So that's why you see the data, you find that okay, I want to predict humidity, or I want to predict this prognosis value, like fungal infection happens because of this. So that's why you always have to do X train and Y train. So I have splitted my data into X and Y. So for both the train and the test. So this is X train, Y train, X test, Y test. So uh, just like a recap for what I am doing here, and that's it. Like that's what I'm going to use to fit my data. So I'll say model dot fit X train, Y train, and I will ask what is the score. So my score is 97. So my random forest classifier is going to give me an accuracy of 97% when I ask it to predict a particular disease. So that is like, this is all like for a data analysis thing. Now what is random forest classifier, what is SVM, what is decision tree, what is linear regression, what is logistic regression? It's like a huge another chapter in its own. And it can be covered in another workshop because it's statistics, and it is a model that people have worked on. They have written papers on it, and from those these libraries have been made. So what I am doing, I am being a very ungrateful person, and I'm just using the random forest classifier library. But random forest classifier library has its own code which does certain things so that it can predict the data. So that's here, and all of this is present in the sklearn. So you have to do a pip install sklearn so that it installs in your Python, because Python does not have it prerequisite. Even NumPy and Pandas, you would have to do pip install NumPy, pip install Pandas, pip install Matplotlib, and then you can use those particular things, particular libraries. So and then this import again, like from this library import only this. why I am writing, it will work without just I say import sklearn, but then I do not want to import all the libraries inside sklearn. So sklearn has random forest classifier, it has svc, it's coming, like I have a code here also, but I do not want to import all, so I'll just import this. And as I said before, a good practice is always having these imports on the top. But as I had to show it here, I just added it here. But it should be on the top. Then this is your way of doing your random forest classifier. So it's a classification way. It will give you a classification report. So classification report is uh, a function inside sklearn, so you can get what all the precision, recall, f1 score. Now these things would seem random to you, but it also holds meaning when you are doing data analysis. Like you see your f1 score and you understand, okay, this is the score, so my data is working good or bad. So these values have an impact. And then you can find your accuracy. So what is your accuracy? It is 0.98%. So these values have an impact on your data, that's why we see these data. Now macro average, weighted average means this is also accuracy, but a weighted accuracy. uh, so weighted accuracy means, for example, my data set would give a range of accuracies, and I would find a mean of it. So that's what weighted average accuracy is. So it is all the same. But then, yeah, we need to like dig deeper into it to really understand the words that are written over here. It's not like it's not something right now I can explain, but then there is scatter plot. So I have a XY prediction, and it will show you a prediction. You can see there is one outlier that has been left, and then all other are actually predicted well. So it's a straight line. Sometimes it would be a curved line or whatever line. So that is what the scatter plot shows. Then uh, scoring, so this is like svc is also a way of classification. So I have kind of given like how naive based classifier, random forest classifier, so these are just words right now for you all. But like this is classification techniques in machine learning or data science. So these are the words that you can google and see what it means, and you will know. And then having those classifier do some things and getting a chart. So that is there. There's something called as xgb. Xgb is xg boost, extreme gradient boosting. It is also a classification technique which gives best prediction out of all of the ones that have been there. So out of linear regression or whatever you do, extreme gradient boosting is a better classifier. uh, some other classifier would be better for your other data set, but for this data set, xgb is the best one. So yeah, the in data science you also do trial errors. So you kind of look into what model fits your particular data set. Not all data set would work for decision tree model or extreme gradient boosting model. Some for some linear regression would give the best score, so linear regression is the best. So that you need to do trial error, but all of them have like something common, that is x train y train. So the exploratory data analysis, so those data analysis is like something which is done commonly for all the classification. So that's why that's the crux of it. And then you just have to have this library, and you can fit a data and find the accuracy of that data. And then find what is so there's something called as feature importance. Feature importance is the columns that I had shown. The columns like itching, abdominal pain, back pain, those are called features. So there is something called as feature engineering, which means like you understand the importance of a feature, you do certain things with the feature, and you get a good value out of the data. So the feature importance graph shows you like what feature is the most important for your prediction. So for me, I see abdominal pain has given me good results, so I'll choose this. And then I see that acute liver failure kind of didn't really give me any input, so it's not an important feature. Or restlessness has not given me any uh, data out of it, so it's not important. But continuous sneezing kind of and made me understand that this disease actually has continuous sneezing in it. So just something where you can do things. And then this is like the last one is just a collab, like one thing collaborated, so all of the things in one place. So where you have logistic regression, decision tree classifier, random forest, svc, xgb. So just so that you have a little understanding of these words. So before understanding, you need to know the words. So now you know the words, now you can go back home and read about it. There are a lot of medium articles and a really good YouTube tutorial that I follow is called Sent Dex. It helps me with my interviews. So whenever I have an interview, I kind of go there and I look at those videos, and it helps me give the answers for these. So he has explained all these in a very beautiful way, and you could read those. He also has like Python fundamentals and all of those tutorial channels. So it's a good tutorial channel you could follow. And yeah, that's it. I mean, thank you so much for listening for so long.
I just have one question. In a lot of interviews, they give you JSON file, and we have to convert those data and all. Can you explain about JSON again?
Oh, yes.
Formatting.
Um, so, like, what you can do, like, a common thing is having everything, even if it's a JSON file, do not get overwhelmed. You can use those JSON file into a data frame, and then you could do all kind of manipulation on a data frame.
So
So,
if I return a value, it will return a dictionary.
yeah.
Okay.
Hmm. And then you can do your manipulation like adding or finding a value. So it's just that, like, your person.json is a particular thing. Use this, and you could say, find name, and then it will give you name. Or if you want to have it changed to something else, you would have to write a code to change it, and then it will be able
So
to
first,
change it.
I use like methods like head or
Yeah,
something
yeah, to
to get the data
understand
which is JSON
that,
and
and then it will be done. But the common way of doing is like, for anything, you just load everything in a data frame. So load your JSON in a data frame, load your CSV file, load your XML in a data frame, and then work with your data frame. One tip that I could give for an interview is you always think and you always speak, even if you do not know. Not something where you beat around the bush, because they kind of understand that, but where you kind of tell them that, this is the problem statement, and if I have to do a certain thing, I can write an algorithm for you. I can write a code, but not as of now, because I need to go back and understand the syntax. But for an algorithm, what you can do. And people, I think interviewer, most of them have liked my answers, because they were like, okay, you have a kind of thought process, and they kind of related to the thought process. They questioned me back about the thought process. So having that logic and logic building and everything clear helps you crack it, instead of knowing a syntax, because no company you are working has the same tech stack. So I never really go with the tech stack, like, even if you give me Java, even if you give me and React, or if you give me any other language that is there, uh, you only need to know how you would process things, so a flowchart algorithm, and then you can go Google, and right now there is Chat GPT. So I don't know why we need to know a syntax. We can just so one additional thing that I have recently tried is like looking at the API of ChatGPT, calling the API and doing certain things around it. And I feel if we kind of build on this approach, so as I said, the tutorial syntax, he has something where you kind of, so what I'm doing here is OpenAI has a key in with them, so you can just download it and you can get a way to authenticate, so that you can get pass and access the API. You can have a request that you want to access this API. So I don't know if it's visible, but yeah. So this is the API. So I would want to hit the API. It has all this header. It has this JSON. So I give all of this value to it, and then I kind of ask it to give me game description, and it does give me that. I think Visual Core Studio and all of these have an extension also for running this kind of ChatGPT thing, and you can build games in Python. You can do a lot of things. So this is just an extra thing that you can look into because we have ChatGPT. But the most important, like ChatGPT cannot replace us because algorithms can be made by us. So we kind of know how to do it. It can write syntax for you. So that's why I would really suggest to work on your logic building and algorithms, and then understand the concepts. Like I did tell you about regression, classification, and all of this. Understand this concept, and then you could ace in your interview. So